Hello everyone and welcome to this video.
So today actually we are going to introduce the numbering system and why it's actually important to understand the different numbering systems and convert between them. So let's start with the basic and very well known numbering system, which is the decimal numbering system. So if you remember when you started to know about the numbering system, it's actually like counting 1, 2, 3, 4, 5, and so on, right? Or to be specific, we are starting counting at 0, 1, 2, 3, 4, and continuing until 9. After 9, actually, you are doing something very important, which is just repeating or reusing the numbers from 0 to 9, right? So if you want to write 10, this is not a new symbol. It's just 1 and 0, right? And then continuing as 11 and so on until 19. 20, you're using a new number, which is 2, 0, and continuing in the same way. So since all of us are understanding what's happening here and the decimal system, so let's try to use the same concept with binary numbers. So if you look here, the decimal system, which in another way we name it as base 10, okay, the maximum number can appears here is 9, right? So base 10, the maximum number appears there 9 and then reusing. So binary numbers, which in this case we can say that it's base 2. What's the maximum number that can appear in this base? It's 1, right? So here in base 2, we are dealing with 0, 1, and that's it. Again, if you return back to the decimal system, we are reusing 0 to 9. But in the binary system, we are reusing 0 and 1 only, and that's it. So let's try to see how the binary numbering system works. So as you can see, like we are having two options only, 0 and 1, and that's it, right? So first of all, to understand why actually we are interested in the binary numbers. As you know, like when we was talking about the machine language, and the machine actually can't understand any language except zeros and ones. So anything written in zeros and ones, it will be understood by your computer. Otherwise, it will never be able to understand what do you mean by this C code or Java code or whatever. So this is one thing actually. The other thing is that we will need to convert the numbering systems at least for like one objective, which is we can convert from binary to hexadecimal in order to shorten our zeros and ones. Like we have a lot of zeros and ones. Let's take it to another form to make sure that when representing it, I'm not writing like 20 lines of zeros and ones. We can reduce that using different representation of data. Okay, so let's review how we play with the placeholders. So for this number, 3125, if you remember, 5 is the ones placeholder, 2 is the tens placeholder, and so on, right? 1 is 100s, and 3 is 1000s placeholder. Okay, and when actually trying to say this number, we are saying 3000s, 100, 2 tens, and then 5 ones, right? And when mathematically going to calculate that, you will just multiply 3 by 1000, and then 1 by 100, and then 2 by 10, and then 5 by 1. Let me write it in another way, which is 3 multiplied by 10 to the power 3, and 1 multiplied by 100, which is 10 to the power of 2, and this is 10 to the power of 1, and let me write this 10 to the power of 0. Try to see the pattern happening here, okay? So if we try to look at the placeholders and think about the decimal system and the binary system, can we do the same thing with the binary system? Look at each placeholder, and if we are dealing with the binary system, in this case the base will not be 10. In this case the base will be 2, right? So going to this binary number, and can we see what is this number? Yes, let's apply the same idea, which is here's the first placeholder, and then second, and then and so on. So in this case, actually the first one will be 2 to the power of 0, right? Where 2 to the power of 0 is just 1. And then the second one, 2 to the power of 1, which is just 2, right? And here 4, and here 8, right? So if we want to find the decimal representation of this number, what we have to do? Remember from the decimal how you did it, right? And return back here and see. So in this case, I just need to multiply 8 by 1, 4 by 0, 2 by 1, 1 by 0, right? So in this case, this is the mathematical representation, and finally 1010 in binary can be converted to 10 in decimal. So this is how actually you convert from binary to decimal, and as you see, it's not hard actually to do the conversion, because the concept is the same here and there, right? You just need to know the placeholders, and then substitute with the numbers as we did before. This is 2 to the power of 0, this is 2 to the power of 1, this is 2 to the power of 2, this is 2 to the power of 4, right? And then multiply each one and then add, and that's it. The good thing here actually, that's always when we are multiplying anything by 0, it's not there, right? This is not there, this is not there. So you have to take care only 1 multiplied by 8, which is 8, plus 1 multiplied by 2, which is 2, and finally the number is 10. Okay, so the bars of 2 actually is very helpful, because while you are converting, this will make things much easier for you. So for example here, 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2, 4, 2 to the power of 3, 8, 16, 32, 64, 128, 256, 512, 10, 24. So for example, what is 2 to the power of 11? Right? And so on, so forth, 2 to the power of 12. The only thing actually, you're multiplying the number before by 2, so this is 4096, and so on. Okay, at least try to put these numbers in your mind, because we will need to work with it a lot when we are dealing with conversions. Okay, so here are the numbers if we are dealing with base 10 or decimal numbers. And as we said, the maximum number that can appear here is 9, because this is base 10. This is base 2, and the maximum number can appear here is 1, right? Why 1? Because actually this is base 2, so nothing can appear related to the maximum number I have, which is 2, which is my base. And then base 16, yes, which is hexadecimal. So what's base 16? Base 16 actually, it's counting more than the decimal, right, which is base 10. So in this case, actually, we have numbers from 0 to 15, right? So this is why actually, as you can see here, we are starting from 0 to 9, and then we are supposed to have 10, 11, 12, 13, 14, 15, right? But if you can see, let's return back to base 10 and look here. This is 10 in decimal, right? Which we can just write it in this way, okay? This is very similar to 10, but it's 1, 0 in binary, right? What's the decimal representation of 1, 0? Let's play the same game. 2 to the power of 0 multiplied by 0 plus 2 to the power of 1 multiplied by 1, which here this represents 2 and this represents 10, right? And then let's play the same game here. So this one is 10 to base 16, right? So 10 to base 16, if I want to get the decimal representation for it, you will find that this is multiplied by 16 to the power of 0, which is 1. And this is multiplied by 16 to the power of 1. And then adding them will give you 16 in decimal. So in this case, it will be confusing to have 10 here and this 10, right? Because both of them are the same. So how I can differentiate between them? This is why actually we said, okay, after 9, let's take off 10 and represent it with A, 11 represented with B, C, D, E, F. And actually, this representation is used because it's only one digit, right? We are adding the second digit when we exceed the maximum of the base, right? So the base is base 16, the maximum number can be represented is 15. So when adding 1, you have to return back and utilize whatever or reuse the numbers that you already have. The same thing we said here, we are reusing those, right? We are reusing those, and here we are reusing those, okay? So one very important question here, which is, can I invent my own numbering system? Yes, you can. Let's say I will invent base 7. So base 7 will start 0, 1, 2, 3, 4, 5, 6, 7. Hey, stop. You can't represent a number greater than or equal to the base, right? So it is base 7, so the maximum number that will appear here is 6. So how I represent 7? It's 1, 0. How I can represent 8? It's 1, 1. How I represent 9? 1, 2, and so on, right? Whatever the base system you want to invent, you can invent whatever base you want. The only thing here that we are interested in is the famous ones, right? Base 10 is the regular one, which everyone in the world is dealing with it, right? Base 2, it's actually for your computer to understand all the syntax and everything, as we said, is inverted or converted into the machine language, which is zeros and ones. And then base 16, it's mainly used to reduce the number of bits when we are dealing with, reduce the representation of the number of bits when we are dealing with base 2. And we will see now an example for that. There is another system, which is octs, which is base 8. And this is again 0, 1, 2, 3, 4, 5, 6, 7, and then again 1, 0, 1, 1, and so on, continuing in the same way. So those are the most famous ones. Base 10, which is the decimal, base 2, which is the binary, base 16, which is the hex, and base 8, which is the oct. Okay, so now let's see, for example, here I have 3AB base 16, and once I said this is base 16, you know that this is actually corresponding to 10, this is corresponding to 11, right? But we are not writing them in this way, just not to be confused with the remaining numbers coming after the maximum, which is 15 in this case, right? Okay, so how we can know the decimal representation of this number? So it's the same game. Exactly what you did in base 10 is the same what you did in base 2 and what you will do now in base 16, right? Placeholders and multiply by the base based on which placeholder you are playing with. So this is base 16, placeholder, the first placeholder, 16th placeholder, and then 256, which is 16 square. And then how to find the mathematical representation of this number. Again, you will do the same thing, right? You multiply 3 multiplied by 256, and then 10 multiplied by 16, and then 11 multiplied by 1, right? And finally getting decimal representation, which is 939 base 10. Okay, so what is the largest number you can represent using 4 binary digits? Okay, so for each binary digit, I can represent, let's say I have only one digit, okay? One digit I can put there either 0 or 1, right? So using only one digit, I can represent two whatever entities, numbers, whatever. Okay, if I have two digits, I can represent in the following way: 0, 0, 0, 1, 1, 0, 1, 1. So maximum I can represent for entities or things, whatever. So continue in this way, you will find a certain relationship, right? So let's add here one more digit. What are the number of representations that you can do? 8, right? Because you will start from 0, 0, 0, 0, 0, 1, continuing until 1, 1, 1, right? And those are 8 entries. In this case, we can represent maximum 8 entries. So now the question is, if I have 4 digits, what is the largest number you can represent? In this case, it is 16, right? Because you will start here from 0, 0, 0, 0, and then 0, 0, 0, 1, 0, 0, 1, 0, continuing until 1, 1, 1, 1, right? And those are 16 integers. Okay, so from here, you will find that as far as you are adding like extra digits, you can represent larger numbers, right? So for example, let's say that in Iowa we are having 99 cities, okay, and we want to represent each city with a binary code. So how many digits we need to represent all these different cities? So in this case, you will say, okay, I have 99, right? And from here, you will find that the relationship is as follows. If I have one digit, it's 2 to the power of 1, which will give 2. If I have 2 digits, it's 2 to the power of 2, which will give 4. If I have 3 digits, it's 2 to the power of 3, which will give 8. If it is 4 digits, it's 2 to the power of 4, which will give 16, right? So now I have 99 and I want to know the nearest number, right? So in this case, the best way is to do what I told you actually, which we have to return back to here and then 99. So I'm actually here, and now I want to decide how many digits I want to use. So in this case, you have to choose between 6 or 7. So which one I will choose? If you choose 6, in this case, you can represent 64 cities only, right? If you choose 7, you can represent up to 128 cities, right? So you will represent the 99 and you will still have more codes to assign in future, for example. So in this case, the answer here is 7. Okay, so here we will need 7 units, or let me name it digits. Okay. So the same thing actually, if you look at the base 16, which we already mentioned, that you will find like A corresponding 10, B corresponding 11, and so on, which we went over it. And then, for example, here, if I have this number, okay, which in decimal it's 51794, okay, and this number here in hex, it is 110010010010010010, okay. So what about trying to write this number in hex? So converting from binary to hex, it's a very easy situation. Why? Because the only thing you have to do is just group each 4 digits and represent them in hex. So 0010 in hex, this is 2, right? So I will just write 2 here. Next 4 digits, it's 0101, this is 5, so I'll write 5 here. 1010, I think we started representing binary and stuff in this video, was 1010, which we found that it's 10, right? But 10 in hex is A, right? And then going here, what is 1100? Okay, we have different ways to get it. The first way is just to use the placeholders and play with that, which you will find that the first one is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, which is 4, 2 to the power of 3, which is 8, and then 8 plus 4, which is 12, right? Another way, I know that 10 is 1010, 11 is 1011, right? Which is B. 12, 1100, which is C. So this number here is CA52. Okay, so this is how actually we convert them. Group them in 4 bits, and then take each bit or each 4 and represent it in hex. Okay, so it's 2, 5, A, C, and finally you can just write it as CA52, and then this is in base 16. Okay, and make sure to write 16 as a subscript to tell me what is the base. Okay, so if you look at this, I think if you are using Windows machines, you saw this a lot, right? The most important part here is that if you look at top line, okay, you'll find the following: 0x, which is telling you, hey, this is written in hex, okay, and then 000050, and then the next one again 0x, which again telling you it's written in hex, and so on and so forth. So when you look at this number and consider writing this number in binary, okay, so for example here I have 1, 2, 3, 4, 5, 6, right? These are 6 zeros, right? In hex. So in binary you will take each 0 and represent it with 4 digits, right? So you will have 0, 0, 0. This is for only 1 0. So just to write these zeros only, you have to have 24 zeros, right? And then the 5, you will add 4 more digits, which is 0, 1, 0, 1. And then the 0, you will add 4 digits. So actually we have 32 units here. And then continuing with this, so to write this address in binary, you need at least 10, 15 lines to write it. But in hex, it's very easy to write. This is why actually we prefer hex in representing the binary addresses or numbers, or when you are writing something related to the computer itself. Okay? Okay, so now let's see the conversion actually, how I can convert from decimal to binary. So there is a very basic way to do the conversion, which is the continuous division here. So I will start with 125, And then just ask yourself a question. Is 125 divisible by 2? No. So take 1 here. Now you have 124. Divide by 2, it's 62. Okay? And then take the 62 and ask yourself the same question. Is 62 divisible by 2? Yes. This is why we are having here 0. Okay? And then 62 divided by 2 is 31. And then coming here, 31 divisible by 2? No. This is why we will just leave here 1 as a remainder. And then 30 divided by 2 is 15. And then taking the 15, asking the same question, take 1 here, and then 14 divided by 2 is 7. And continuing in the same way, take 1 here, divide 3, continuing the same way, and finally take all these 1 and zeros, read it from down to top, and then write it, and finally we convert it from decimal to binary. Okay? So again, you have to divide, and every time while you are dividing, you have to ask the question, right? Which is divisible by 2? If yes, just put 0 there in the remainder. If no, put 1 there in the remainder and continue the division with the even number. Okay? So let's see another example here. So this other example is 17. Okay? And if you are doing this in the same way we did before, so 17 divided by 2, which is equals to 8 and R1 or remainder 1, and then 8 divided by 2 equals to 4, remainder 0, and then 4 divided by 2 equals to 2, remainder 0, and then 2 divided by 2 equals to 1, remainder 0, and then finally 1 divided by 2 equals to 0, remainder 1, right? So after that, read it from here to up. You will get 1, 0, 0, 0, 1. But actually there is another way which sometimes it's much easier than just dividing by 2 all the time. What is this way? Start with the nearest number, which is power of 2, near to 17, which is 16, right? So what I'm going to do now is having 17, okay? And then I found the nearest number is 16, right? So 16 can be represented as 1, 0, 0, 0, 0, okay? And then subtract both of them from each other. This will give 1, right? How you can represent 1 in binary? Just here. And finally you get this number, which is exactly the same as this number, okay? For example here, 212, okay? This, if we want to get it using the same way I used now, so in this case actually you have to do the same thing with the division, right? So you will start with, not division, trying to find the nearest number. So you will start with 212 and then trying to go to the nearest number, and in this case actually you'll find that the nearest number is 128, right? Which is 2 to the power of 7, which is 1 and 7 zeros. 1, 2, 3, 4, 5, 6, 7. Okay? And then we have to subtract these two from each other. So subtracting 212 from 128, this will be 84. Okay? And let's do it again. Let's try to see what is the nearest number to 84, which is 2 to the power of something, right? It's 64, right? So here minus 64, and 64 actually is 2 to the power of 6. So I will just add here 1, which is 2 to the power of 6 in this digit, and I will do subtraction here, which will have here 0 and 2. And then 20. What's the nearest number? 16. So I will have here 16, right? And I will put 1 at 16 here, which is 1, 2, 3, 4, and 1 here, right? And I still have 4, and 4 I know how to represent it, right? It's 1, 0, 0. So in this case I will put 1 here, and I'm done. Okay? So again, you have to the two ways, and you have to choose which way you want to go with. Like, there's no preference actually. It's based on you if you like this more or like this more, and that's it. Okay, this is another example for converting from decimal to binary. I will just leave it to you to look over or try to do it by yourself. And then the same way we did decimal to binary, we can do it decimal to hex, right? Which is 125 divided by 16, okay? So in this case, we will have remainder 13, and then we will have the division equals to 7. And then 7 divided by 16, we will have the remainder is 7, and finally 0. And in this case, when we convert this number to this number, you'll find that I have 7 and then 13. What's the 13 in hex? It is D. So finally the number here is 7D. So it's the same concept. Whatever you're converting from what to what, you have to just implement the concept, and that's it. Okay, so now we are done with the conversions and all of these stuff, and let's just like go very quick over these concepts. The first thing is that a binary digit is called a bit. So let's say we have 4 binary digits. We say directly we have 4 bits, okay? And then every group of 8 bits, we call them a byte. And actually all of you know that. Like, let's say when you are dealing with your hard disk, you are saying terabyte, right? When you are dealing with the internet speed, you are saying, let's say 100 megabit per second, right? So here we are saying bit, here we are saying byte, and the relation between them actually is that each 8 bits is 1 byte, okay? So here, this is an example actually for 8 bits, which finally we can say that actually these are only 1 byte, right? Because we know that the relation between them is 1 bit, 8 bits are 1 byte. Okay, also the bit permutations is very important, and we went over it already, but let's stress more. If you have only 1 bit, you can have 2 representations, 0, 1. If you have 2 bits, you can have up to 4 representations. If you have 3, you can have up to 8 representations. If you have 4, you can have representations up to, if you don't know, just like do it in this way. This is 2 to the power of 1. This is 2 to the power of 2. Can you see the relation? This is 2 to the power of 3. This is 2 to the power of 4, right? So if I said like I gave you 10 bits, how many entries you have here, right? So you will say, okay, it's 2 to the power of 10, which is 1 or 1024, okay? So every additional bit you are adding, you are, adding 1 or doubling the number of entries that you have, right? So here, when I started, I was only having 2, and then going next I have 4, going next I have 8, next I have 16, and so on. So you are just doubling by just adding 1 bit. You are doubling the entries that you have for the representation of these numbers. Okay. So when you look at this relation, you'll find that the question that we said, like if we have 99 citizens, or let's say in our class we have 170 students, and we want to assign to each student his own code, a unique code for each student. So in this case, how many bits, or let's say how many bits we need to represent all of them. So in this case, we will say, okay, we have 170 students, and what is the nearest number here, which is 2 to the power of something? We will find that 128, which is 2 to the power of 7, and 256, which is 2 to the power of 8. So actually we will choose this one, right? Because in this case, our class, each one will have a unique code which is having 8 bits. So let's say first one, which is Mike, his code would be 1, 2, 3, 4, 5, 6, 7, 8, right? And then let's say Ryan, his code would be 0, 0, 0, 0, 0, 0, 0, 1, and so on and so forth until everyone is getting his code, right? Okay, so based on that, we are done with going over the numbering system, looking at the binary numbers relating to the decimal numbers, and then looking at the hex decimal numbering system, and then converting from one to the other. And after that, we went over just some basic definitions, which are the bit and the byte and permutations when adding the number of bits to a certain number. Thank you very much for watching.